I'm good. I think I get it. She hasn't had as much time. I don't know if you have any questions.
Yeah,
I want over from your team, and
what'd you say?
I said I went over a little bit before we took the meeting today, so I should be good.
Okay. Should we go over? Let's see. Um, no, let's just push it up. Oh, yeah, I don't know. You guys know the new Z-score formula?
Yeah,
It,
this one
you guys know what that little X with the bar over it stands for?
with the X with the bar over it.
Yeah.
Is that the it's the value? Yeah, it's like the value you're trying to find relative to the data you have, I guess.
Yeah, pretty much sample mean. Instead of like the one thing I learned this week was that pretty much stands for the sample mean instead of one variable. Like if you're trying to find your score or somebody's score specifically, you would use the old Z-score formula. The new Z-score formula is pretty much for like multiple variables or multiple. I don't know how to really explain it, but it's a sample mean, so it's a sample out of a group instead of one specific person's score. And then because of that, you have to square root n at the bottom. Okay. Anything else? Let me go over.
What's up?
What's up? Hello.
We were group meeting. That's awkward. Sorry. So,
The size 25. Should we practice one real quick? Should we try number 9?
Okay.
And then if we get it right pretty easily, then we'll go to the quiz.
Sure.
I think I
Let's see.
hold on one second.
We're gonna move.
Just up on your project.
Oh, where am I going? Oh, you're breaking up. I can't hear you. Oh no, I think I lost you. Still there?
Yep. Oh,
Oh, there you are. Okay.
what is happening?
So I have the appellate pulled up, so let's see if we can figure this one out. So the question is, a sample size of 25 is taken from a normal distributed 2011 sales data. What is the probability that the observed sample mean is greater than 50? Okay. So I'm going to go ahead.
What's the probability? This is using the data that you, like the pair computing stuff, right?
Yeah, I guess I should read the first part of it before I go into.
Yeah.
Suppose pair computing sold an average of 45 per minute in 2011. Yes, that means they sold 23 million with standard deviation of n. Looked at their own sales data and determined that they are normally distributed. Okay. So if we were going to do that, we would take the probability. Oh, I gotta look at my notes. So we take the percentile. So what percentile are we for number
9? Greater than 50. What is probably?
Was it 50, right?
Yeah. But that's not the percentile. because it's half a standard deviation away from the mean.
Oh, I just lost it.
So it's saying at the sample size of hello. Um,
So confused right now. Oh, freak. I had the other lesson pulled up. I've been looking at it. Hold on, I gotta close this stuff out.
I think this is really simple. You just plug in 0.5 in here.
No, it says sample size n.
9, it's 00621.
So 0.61 is the answer, but if we take so using that formula, the sample size n is taken from the normal distributed 2011 sales data. Was the probability that observed x is greater than 50? So okay. So we have to first find the z-score, right? So you put the you have to put the percentile and find the z-score, and then we could implement that into the new the data. Or somebody told me, or I was talking to a TA, and they told me a formula that's easy to remember, or that you use, like instead of like trying to figure it out algebraically every time. It's QZ plus M equals X, or in other words, the deviation plus so deviation times the z-score plus M, which is median, equals X. So I don't know. He just said that's a huge thing to remember when doing these problems. So if we can find when we find the z-score, so we put the percentile, which it gave us the percentile, right?
No.
At the top, maybe? No, standard deviation. Oh, geez.
It gives you, I've got it. Here we go. It's 10.5, 5, 2.5. I think that's the right answer.
So 9. Okay. Didn't tell me the percentile. It was probably
Yeah, okay, that's right.
greater than 50.
So yeah, you just have to plug everything into the formula. So you take the value and you subtract the mean and you divide it by the
Standard deviation divided by
standard deviation, the sample size, square root of the sample size. And that'll give you the z-score, and then you plug in the z-score to the applet, and that's what the answer is.
All right, let's try it. I'm gonna do it on Excel real quick. So equals does it equal 50? We're gonna go sample mean is
I
50.
thought this was supposed to be like the answer, and I was like, that's not the answer, but then I realized it's the z-score. That makes sense.
The thing is, we don't know x, so we gotta find x.
How do we not know x?
So x
X is greater than 50, right?
right. So on it'd be shaded to the right, but we have to find x and then put it into the formula to find z. Or maybe
I
back.
was just talking about the probability X is going to
Find z.
Oh. No, I don't.
5.
Oh, that's how I got it. I'm tripping. Okay, yeah. We're on 9. Yeah?
Mhm.
Quantity, size.
No. You do 50 minus 45 divided by standard deviation, which is 10, divided by the square root of sample size, which is that. So you got 5 over 10 divided by 5, which is 2.5. You plug in that z-score here, and then everything to the right of it, and you get that tiny number. Yeah.
Does that work?
Yeah.
I'll give you the rest. They gave you the right number.
Yep.
So 50 was considered the sample mean.
50 is, you plug in 50 for x, and then that'll give you like the z-score. Z-score and shade everything to the right, and you'll get the answer.
Okay. I just didn't know if 50 was definitely considered was considered
The value.
yeah, or the value. All right. Whatever.
Okay.
Sounds good to me. Let's try it out. Go to here.
And we'll go to find the combined area under.
All right, number 3. Here we go. Use the normal probability. Combined area and standard normal curve is the right of to the right of the left negative around your answer 3 decimal places. Example following. Okay. Was it asking for? What's the probability?
Do not round until your calculation is complete. So the answer is yeah. Yeah, it goes round. I rounded and didn't round last time, and I got them both right. So I don't think it matters. You just can't round beforehand. Is that following?
Hold on.
Do you have 3?
I'm figuring it out. Hold on. Combined area, standard normal. I don't get what's so hard about this, but 1.358.
What'd you get?
Not 3. Where'd you get
You
3?
haven't gotten 3?
Huh?
Did you get an answer for 3 or no?
Oh. Well, I just did what they told me to do. What's the probability? And that's a probability chart for normal distribution. I just plugged in the numbers like they said. It's 0.1745.
Yeah. So rounded it to 0.175. That was what I got. What we both got. Okay.
What did we compare it to? What Brandon? I've not seen Brandon's thing, but we compare it to his. See what he got too.
We got the same thing.
Okay. So 0.175. Holy cow. Okay. Which of the following will have smaller standard deviation and 9 observations randomly drawn from the population? Which of the following has smaller standard deviation? Population distribution of individual So, wouldn't the distribution of sample means be smaller?
That's what I guess, but I'm not really sure why.
Well, in the equation, like the new z-score equation, you have to like square root the n, or the population, which brings the number way down. If you ask me to explain it, I can't explain it to you. I was looking at the equation here.
The phone have a smaller standard deviation with 9 observations. Yeah, that's what I would guess, but I'm not exactly sure why.
Yeah. See here.
Brandon got the same thing.
I did.
Yeah.
I'm trying to get to that stupid thing. I can't find it.
So the following results implies that the spread decreases as the sample size increases. The law of large numbers. No.
Which of the
Yes.
following results implies the spread of x decreases as the sample size increases? Spread of the sample mean decreases as the sample size increases. Oh, I don't know. I have no idea on this one. Sorry.
Pretty sure it's the law of large numbers.
I know what the law of large numbers is, but
Huh?
I know what the law of large numbers is, but which the following implies.
As there's more data, it will be closer to like the expected mean, so the spread will be smaller.
Yeah, that makes sense.
I think. But
Makes sense when you say it.
yeah, technically, I think the central limit theorem kind of has the same theory. You know what? I think it's actually the central limit theorem, because the law of large numbers talks about the mean, but the central limit theorem, that's tough to say, it talks about distribution. As the sample size increases, the distribution becomes more normal, which would mean that the spread in X changes. Yeah, it's the central limit theorem. I think Brandon said D, but I don't think it's right.
Well, Brandon's here.
I think D. I'm pretty sure it's C though.
We could try it. Anyway.
We got two shots at this.
Each one of us do. Use
Yeah.
the following information to answer the next 4 questions. Okay, scores the quantitative portion of GRE approximate distribution when the mean equals 150 and the standard deviation 8.8. Scores, what does that mean? ETA? Estimates? Oh, it's a source, sorry. DNA earned a score 1/6 and the quantitative portion of the GRE was a z-score corresponding to the DNA score. Okay, since she is looking for the individual, she is going to use the old z-score formula, which is z equals x minus m over deviation, right?
What?
I'm
Sorry.
going to try it. So I'm going to go equals.
For some reason my speakers aren't getting very loud. Seems like the same kind of stuff so far. We're talking about last lesson.
Okay. M is 1. Oh, what is it? What the heck is it? Oh, okay. Minus 150 close parentheses divided by deviation, which is 8.8. What is z-score corresponding to n-score? Okay, I have 1.045. What do you guys get?
Yeah, we got the same thing.
What did Brandon get?
Huh?
Let's see.
What if we
What
get?
did Brandon get? Yeah, he got the same thing. 1.045. Okay. What is the probability that a randomly selected student group will cover a score above 160 on a reflection G or E? Example, if the answer is that, you will enter that. Okay. So this one is the you have to find X, or are we given X? Yeah, X is 160, right? Number 7.
Yeah.
Okay, so if we have X, we're gonna go X, so 160 minus U, which is what was it? It was like 180 something. U is 150, 50.8 parenthesis divided by standard deviation, which is n 8.8. 8.8 divided by the square root.
Sample size. This? There's no n in this equation.
Square root of n. What is n? N is considered. Oh, we have to plug that into the right way to plug that into that little thing. I screwed up. Find X. Dang. Let me think about it.
Oh crap. Oops.
What is n? I can't remember what n is. Do you guys remember?
Wait, which one are you? You're on 7?
Yeah.
For that one, you just have to use what you got from 6 and plug it into the applet. So you plug in the z-score, and then it's just everything to the right.
Okay, so 1.045, and then it's anything above, or what does that say? What is the random selection students will score above 160? So it's anything to the right, right?
Yeah,
So it's the area of that is 0.148.
yeah, that's what I got.
I don't know. Let's give it a try.
Yeah. Does it really want us to calculate the z-score? Do you have to calculate the standard radiation? It doesn't give us anything. Oh. Oh, this is still tied to the same stuff.
Right.
Oops.
What?
I just messed up on this, on the question 8.
Oh. What does the z-score correspond to the sample mean of these students?
So it's basically asking what this is. You're right. So it's 9.2 divided by divided by 8.8 divided by square root of 5. That's the
So we have
answer.
to find the mean of those numbers first, right?
Yes.
It's still one funny.
Hmm?
Funny, it's 160 still.
Yeah,
So 160.
it's the same thing. I just want you to plug in. Let's see, what did he get? Yeah, okay, I got the same thing. Did you get it?
Minus mean. Eight divided by standard deviation of 8
Mhm.
square root of n. Now we have to know what n is. Anybody know what it is?
Number 9.
This is using the new z-score formula, right? So new z-score formula is sample mean minus the mean divided by a standard deviation divided by the square root of what?
By the square root of the sample size? Is that what you're asking?
No, yeah, on the new z-score formula.
Mm-hmm.
Like, what is n? I can't remember what n is. Is that the sample size or something?
N is the sample size, so yeah, it's 5 for this one.
Okay, so 5. Whoa, I don't know if that's right. What'd you get?
I got 2.338.
Yeah, so did I.
Yeah, that's what Brandon got.
That seems a little weird. Because the z-score, I don't even know if a z-score goes that high. 2.338. No, I guess it does. It was way the heck out there. All right, guys, ready to move on, or you guys already moved on without me?
Yeah, we're on question 9. Yeah.
So what's the probability of 5 grams? I will have mean score that is greater than mean achieved. Uh-oh.
Hmm?
What's the probability of 5 random selected systems? You guys know how to go to about number 9?
Yeah, so you just plug in what you got for question 8 into that applet,
Oh,
and yeah,
and
and
it's the area,
the right again.
0.0097.
Yep.
Except the rerounding, so 0.10, 0.010, 0.01.
It round places on this one.
Oh, 1, 2, 3, 4, 5. 2, 3, 4. Only have. I'm guessing it's all. Yeah, it's at 0.0097, right?
Yeah.
Is that what Brandon got to?
Yeah. Yeah, he got that 0.0097.
Yeah, that's what I did. Okay, next one. Suppose the mean GPA of BYU Idaho since 3.5 standard deviation is that. What is is one of the distribution levels less skewed. A random sample of n students will be drawn. What is the shape of the sampling distribution of random variable x, which prevents sample mean of 81 students who are selected? C is approximately normal. The mean of 81 students. I don't know. I think it was pretty normal, isn't it? Hello? 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 You there? I think your thing is off. Can you hear me? Can you hear me? Hello? Hello? You? I can't hear you. Can you hear me? Can you hear me?
One sec.
Oh
My
yeah.
is just broken.
What happened?
I have no idea.
Mine just crashed. My computer, or not my computer, but my Hangouts crashed.
Oh, sorry, man.
What number are you on?
I was just making sure, like before we broke up, that that number 10 was approximately normal, correct?
Yeah.
Yes.
Okay. Number 11 was the mean of distribution of sample mean for possible samples of 80 size 81. So it's just plugging the 81 into that formula, right?
Well, but it actually says it. It says suppose the mean of BYU host students is 3.5. It says it in the question.
Because the sample mean, the distribution of sample means is the same as the mean of the distribution of the sample means is the same as the sample mean. That makes any sense. Probably.
Yes, that is correct. Are we still using the previous data for this?
Yes.
The next 5 questions. So yeah. All right. We're going to go parentheses 81 minus the mean, which is what? GPA is 3.5. What the? 3 point. I gotta think about this. So sample mean. Sample mean is 81 minus the mean. Whatever. I'm just gonna do it. And then you get the standard deviation, which is what? 0.7, 0.07. So 0.7 divided by square root of n, which is 81. Close parentheses. Yeah, I got holy garbage. 6.03?
For
For
12,
12?
0.078.
What's that?
For 12,
Yeah.
it's 0.078. You take the standard
Okay. I must
DV.
have done that wrong. So I have a sample mean. They gave us a sample mean.
Yeah. So
Which
for
is
the standard deviation, the formula is just the original standard deviation divided by the square root of the sample size
right? So it's 0.7 divided by 81.
by the square root of 80.
Square root of 81.
Yeah, so 0.7 divided by 9,
Right?
which is 0.078.
Yeah, but what about the first part of the equation?
What for that's the entire equation for the standard deviation. It's not the same equation as the as whatever the other one we were using before is.
The z-score. We're trying to find.
This is the equation that we used last lesson, just the simple one where it's just the standard deviation divided by the square root of the sample size.
And that gives. Okay, I'm going to study that. What's the mean of the distribution? One possible sample size. Okay. So 0.0. Oh my gosh. 0.08. Let's see how many times.
0.078 is what I got.
Yeah, I did too. I'm just wondering how far we want this around us. Oh, it says round answer to one decimal place. So 0.1. That doesn't make any sense.
Wait, what? It says round your answer to 3 decimal places.
Round your answer. What number are you on?
12?
12?
I was on 11.
Oh, okay.
Oh, 11 is just 3.5.
Yeah, that's what I thought. Everything makes more sense now.
Yeah. Sorry, I thought you were on 12. My
No,
whole
it's
thing
okay.
crashed.
I just want to make sure I got 3.5 right because that seems a little crazy z-score, to be honest. So I'm going to go 81 minus the mean, which is. Sorry, I'm a little behind, guys. I just got to make sure I know this crap. Minus the mean.
Okay, are you on 12 right now?
I would be, except I don't know where the mean is on this. I can't find it. Hello?
Oh,
You hear me?
can you hear me?
Yeah. So
Okay.
I just want to make sure 3.5. Oh, yes, I want to correct it. Oh my gosh. Can you go over just quickly brief over the equation you had on number 11?
So number 11, we didn't use an equation because the mean of the distribution of the sample means is the same as the sample. Then they're the same. So if you look up in the information, it says, suppose the mean of Idaho students is 3.5. That's the mean that we're using. So that's the answer for number 11, if that makes sense.
You're right. You're right. Okay, number 12. That's where you had the point. Let's see, erase this real quick. That you have 0.078.
Yeah.
Okay. Number 13. Okay, number 13 was the probability of the mean of GPA of 81 random selected students less than 3.3.
Is it 0.46?
I can't really hear you guys. You're breaking up pretty bad.
Sorry.
Yep, didn't hear that either.
Okay.
All right, let me see. Let me think about it. Does it mean GPA for 81 selected students will be less than 3.3? I don't know how to do number 13. Have we got any ideas?
The bigger one, where you have the value.
Dude, I'm sorry, guys. I can't hear anything you're saying.
Breaking up or no?
You guys sound like straight up robots. I can't hear anything you're saying.
On my
I can't hear you. I'm just gonna try to keep. I'm gonna try to work this out real quick.
just switch. Okay, does that work better?
Ah, yeah, that's much better.
Get rid of the video.
Alright, that works.
You can still hear us, right?
Yeah, I'm just trying.
Okay.
I think we definitely have to use a palette thing for this.
For 13, it's just the equation. So you got to use the called it's
Sample
the
mean equation, the z-score sample mean equation.
where you have the value subtracted by the mean divided by the standard variance.
Say that again.
So it's x with the bar over it subtracted by
Yeah.
u divided by the standard deviation
divided by the square root.
divided by the square root of the mean, or the sample size, really.
So in this case, I'm saying 81? I just don't know what sample mean x is.
For x, it's going to be 3.3.
Okay, yeah, you're right. Okay, I kind of get that. That makes sense. 3.3 minus 81. No, what does it mean? You gotta figure that out.
The mean is 3.5.
Minus 3.5 divided by
2.47.
divided by NUD
2.5.
Yeah, I just missed it. I had everything. I got 5, 6. Because we subtracted this by this. Doesn't matter. It's actually on the left side, so this one goes negative. Because it's a negative z square away.
2.
Was that what? Did you say 2.57 or 2.56? Randomly?
Yeah, let me redo it.
What did he say? 2.57?
All right, what did you come up with?
So didn't get it right.
I got 2.56. What'd you get?
Negative 2.57.
Yeah, okay. You guys both got negative 2, or it doesn't really matter. Then negative. I guess that's why he didn't get it right, is because he got positive. So yeah, negative 2.571 should be the answer.
Right.
That's why he didn't get it right, because he didn't have it positive, or he had it positive instead of negative. Yeah, okay, that makes sense. But let me double check that. Oh, it's because I used it around. I used a rounded number.
Oh, gotcha.
Yeah. Okay.
The probability that the mean GPA for 81 random is greater than 3.3. Not the same thing.
Oh, and that's not the answer either.
What?
We just
You
found
have
the
to
z-score.
Yeah, I have to plug that in.
Yeah,
I knew we have to use a pellet.
yeah.
So I'm going to go negative 2.57.
So the answer should be 0.0051. And then will be greater is the exact opposite.
It should be the same though, right? Oh, wait a second. No, it'll be the middle. It'll be the middle and the other side.
Yeah,
Change
middle
there.
on the other side. So it's 0.9949. Oh, but rounded to 3 decimal places, so 0.995. Same with this one, 0.005.
It's just 0.005 for the other one, right?
Yeah.
Okay. Okay, the United States Coast Guard.
Rates of random sample for the quantum recorded.
Okay, no, it's extreme or more extreme. Okay. Oh, equals. Here we go. Okay, so what are we looking for here? That's the problem. I'm trying to figure out. Problem. The last question. I'm just trying to figure out what they're looking for.
Basically, it's just asking for the probability of being
Extreme.
being more than however far away 177.6 is from the mean. If that makes any sense. So like,
So we have to find, let's find the z-score, plug it in, and you should be able to tell.
yeah. Kind of confused on this one though, because it says find the probability that a random sample of passengers. Yeah, that makes
It
sense.
should give us how many people though, right?
No, because you just gotta
48.
calculate. So plug all
The random sample is 48 commercial boat passengers. So X is, well,
X is
48.
177.6.
Bizarre.
No, that's the mean.
That's the new mean. Okay. So it's saying like if you were to take another sample, a random sample, what is the odds that that sample mean is less than 177.6? On the flip side, it's kind of hard to explain. It's not.
You're doing good.
I'm sorry.
You're doing good.
Let me just find the answer real quick and I'll see. Here, I can flip my camera and show you what I'm doing, if this is even legible. I don't know if it is.
Yeah, 177.6 minus 185 divided by
And then this
26 is the mean then?
26.7 is the standard variation.
Okay, standard deviation 26.7 divided by square root of
48. Oops.
Ah, that makes pretty good sense.
Yeah, and then once you get that z-score,
Then you plug
you got to find the probability of it being less than that, and also on the flip side of it being, you have to shade both the left and the right areas, if that makes sense.
All right. Yeah, so let me figure it out real quick on my Excel.
I'm over it, but I'm so good at it. Can I go up from here? That's all I'm saying. Okay. Okay. Sorry, girl. Okay.
Negative.
Okay, so I got, we got the same thing. Okay.
Same thing.
Yeah.
Way I didn't.
What did you do?
You said 185 minus 177.
All right, so 0.055.
Thank you. You told you the answer.
So then you go to the applet and you plug in z-score 1.92.
Negative 0.19.
Yeah,
1.92, right?
It'll correct it.
All right.
And then you want to shade the left and the right.
Look for both extremes.
Yep.
I think. Who knows? Find the phone.
Okay.
Did you come up with 0.055?
Okay, so the only one that we got wrong was that one that I was debating with myself about. On question 5, it's the law of large numbers, not the central limit theorem.
Oh no. Man. We got everything else right though?
Yep.
Oh,
You keep it up.
Boom.
I'm so tired.
Carter, how much school do you have left?
It is my second semester.
Oh,
1.245. 1.2. Oh, what are you doing? 0. Sorry. I'm having you. 0. 4. And 0.
I don't know what is happening. Love it.
Okay.
0.13.
2.338. 0.0097. 3.5. 0.078. 0.005. 0.995. 0.055.
You got all of them right, right, Kyle?
uh-huh. Yeah.
Okay, just making sure. I want to make sure that I didn't get that one wrong twice. Okay. Perfect. Okay. Well, mission accomplished.
Sounds good. You want to do the honors of posting that bad boy on the group sketch board?
Yep.
Do that.
I don't get the point of that. Are we supposed to be watching